So, good morning everyone. I am Gobinta Panta from Kathmandu University, Nepal. I am PhD student. My supervisor is Professor Dr. Deepak Prasad Suedi, who is in Nepal, and also Antonis Papadaki, as a professor of this university. So my my topic of presentation is dielectric barrier discharge for generation of ozone and its application for treatment of water. So let's move to the next slide. This is actual my outline of presentation. First I will talk about introduction, then objectives of my study, reason for using DBD, dielectric barrier discharge, application of DBD, research problem, material and methods, limitation of study, expected outcomes, reference, and finally I will talk about acknowledgement, introduction. Let's start from introductions. So as we know that plasma is fourth state of matters. It's ionized gas or ionized particle in which the electron density, number density is balanced by the ion density. More than 99% of the matter in the universe are in plasma state. Remaining 0.01% of the material are in the other form, and plasma consists of positive ion, negative ion, electrons, meta-stable atoms, free radical, and atom. You can see also from the figure. It clearly indicates the neutral particles, photons, electron, ion, and etc. Let's move to the next slide. When solid is heated, it turns into liquids, and it is also further heated, it converted into gas, and it is also converted into finally into the plasma state. Okay. So property of ozone. Ozone is a triatomic form of oxygen, most powerful commercial oxidizing agent. It is unstable, most generated and used on site. Limited solubility in water, but more so than oxygen, leaves a dissolved residual which ultimately converts back to oxygen. Let's move to the next slide. So how ozone works? It works as an oxidant and disinfectant. So as oxidant, ozone breaks double carbon bonds, creates OH, hydroxyl radial, which breaks the higher carbon bonds, and ozone increased temperature and pH accelerate ozone decomposition to OH radical. As a disinfectant, ozone act which ozone kills by cell line or causing the cell wall to rupture, and ozone attracts all bacteria, virus, and cysts and spores. So advantage and disadvantage of water treatment ozones. Ozone act as a advantage of ozones. Ozone is more effective and disinfecting because of its oxidation potential is 2.07 volt than chlorine in destroying virus and bacteria. The ozonation process utilizes a short contact time, approximately 10 to 30 minutes. Ozone is approximately 13 times more soluble than oxygen in water. Ozone is generated one side, and thus there is fewer safety problems associated with shipping and handling. There are no harmful residuals that need to be removed after ozonation because ozone decomposes rapidly. After ozonation, there is no regrowth of microorganisms. As a disadvantage of ozone treated water, ozone treatment can create undesirable products that can be harmful to health if they are not controlled, e.g. formaldehyde and bromate. The process of creating ozone is the home requires electricity. In any emergency with loss of power, this treatment will not work. Ozone is not effective at removing dissolved salt also. So classification of plasma. Plasma mainly divided into two parts: high temperature or hot plasma, and next one is low temperature or LTP. In high temperature plasma or hot plasma, electron temperature is approximately equal to ion temperature, which is approximately equal to gas temperature, but the plasma temperature vary from 10 to the power 6 to 10 to the power 8 Kelvin, and electron number density or greater or equal to 10 to the power 20 per meter cube. For example, we can see the laser fusion plasma shown in stars galaxy at a hot or high temperature plasma, and low temperature plasma mainly divided into two parts: thermal plasma or quasi-equilibrium plasma, and next one is non-thermal or cold plasma. Thermal or quasi-equilibrium plasma, in which electron temperature is approximately equal to ion temperature, which is approximately equal to gas temperature, and less or equal to 2 into 10 to the power 4 Kelvin. And number density, electron number density is generally greater or equal to 10 to the power 20 per meter cube. In non-thermal or cold plasma, in which the electron temperature is very greater than ion temperature, it is approximately equal to gas temperature, that is vary from 300 Kelvin to 10 to the power 3 Kelvin, and electron number density generally approximately equal to 10 to the power 10 per meter cube. Example of thermal plasma are arc plasma, torch, radio frequency inductively coupled plasma discharge, and example of cold plasma or non-thermal plasma are glow, corona. APPJ means atmospheric pressure plasma jet. DBD means dielectric barrier discharge. My main focus is on DBD, non-thermal plasma, plasma needle, etc. So main objective of, let's talk about my objectives of research work. My main objective is to produce the LTP, means low temperature plasma, by DBD method for generation of ozone and increase its yields in multiple array of DBT tubes system by changing DBT configuration, power supply, and by using the mixture of gases. We can use the mixture of different types of gas like reactive gas nitrogen, oxygen, and noble gases such as argon, mainly argon, to make comparative study of non-thermal plasma at high frequency as well as and low frequency with different gases, air, argon, nitrogen, oxygen, and their mixture also. To use ozone for treatment of water in large volume, mainly to kill viruses and bacteria, because we have done the same treatment for single DVD in the low volume of water, that is the low volume of water in research scale. Why we are choosing the DVD for the generation of ozone and treatment of water? That is, there are so many reasons for the using the dielectric barrier discharge, because it no need the vacuum chamber and expensive devices. It reduces the cost and complexity of the gas discharge operation to generate the high concentration of reactive species which is suitable for surface modification as well as generation of ozone. The DVD can operate it within the high frequency as well as low frequency. Average electron temperature is 0 to 10 to the power 10 electron volt, and average electron density generally lies between 10 to the power 9 to 10 to the power 7 per centimeter cube. DVD technology applied to materials such as polymer or textile is a dry, environmentally and worker friendly method to achieve surface alternation without modifying the bulk properties of different property of material. Cold plasma DVD are suited because most materials are heat sensitive and applicable in continuous process. For example, we can treat the polymer, we can treat the tissue, which is most heat sensitive materials. DVD plasma generated at atmospheric pressure demonstrate excellent results for stability, uniformity, and workability in surface modification, textiles or polymer and other types of materials. In DVD plasma, at least one of the electrodes is covered by a dielectric layer that accumulates the transported charge on its surface. The dielectric layer has two functions mainly. It limits the amount of charge transported by a single micro discharge and distributes the charge over the entire area of the electrode. However, DVD is not completely uniform and has short duration. Atmospheric pressure glow discharge APGD is generated by a lower voltage and higher frequency. When compared with DBD plasma, it is characterized by a relatively long duration, uniformity and surface heating or damaging. But APPJ has advantage over DBD because it can generate uniform reactive gases and can also be applied to the surface of any shaped object. However, APPJ can only be applied to one side of the treated material directly facing to the plasma jet. So previous research scholars have done their research work by using single DVD for single gas system in our university. So we have proposed to use the multiple DVD system in the mixture of gas environment. Many researchers have used single dielectric barrier discharge for material treatment as a dielectric layer. We will use a combination of different dielectric material as a dielectric layer for different gas environment in multiple DVD system for this research work. Atmospheric pressure non-thermal plasma DVD technology are an alternative cost competitive methods to low pressure plasma and wet chemical treatment. DVD, which is also known as silent discharge, example of dielectric material are glass, quartz, ceramics, Teflon, polymers, etc. is one of the most cost effective non-thermal atmospheric plasma source and has attached in So there are so many applications of the DVD plasma, low temperature plasma. We can use the DVD non-thermal plasma in for the generation of ozone and for the treatment of water. We can use the non-thermal plasma in a field of biomedical sector. We can use DVD in non-thermal plasma for the control of pollution and waste management. We can use to produce the incoherent excimer UV sources, and we can use as a fluorescent lamp and plasma display. So we can also use this non-thermal DVD plasma in a silent discharge carbon dioxide laser. We can also use this non-thermal plasma for the surface modification of material or material process. We can also use in greenhouse for recycling process. We can also use in a national defense, construction, agriculture and automobile. We can also use in optics, solar energy, telecommunication and computer also. So we can also use in chemical for the purpose of chemical decomposition. So research problem. My main research problem are to design and construct a multiple array of tube DVD plasma reactor to produce the atmospheric plasma glow discharge at high frequency and low frequency in different gas environments such as nitrogen, oxygen, argon, air and their mixture, to generate ozone and increase its concentration in a lab by multiple array of DVD system and treatment of water, to make a comparative study of ozone yield with different gas, air, argon, nitrogen and oxygen, to study the efficiency of ozone on treatment of water, to analyze the physical, chemical and biological parameter for treatment of sample by ozone, to produce high frequency and high voltage DVD at 50 Hz and also the 50 Hz frequency DVD. DVD are mainly used to generate cold plasma in different situation and environment, different sample and different gases such as argon, air, nitrogen, oxygen in different DVD plasma reactor and ozone analyzer. So material and methods. Let's talk about material and method. We can use the power balance method to calculate the electron number density. So we can use this formula where PAB is absorbed power, 2AB is electrode area and VB is bomb velocity, lost is the electric field, loss of electric field. We can also use this formula to calculate the electron density and we can also on the electron number density by this formula. This is F W H M full width half maximum method. we can calculate the electron temperature by using this formula. So these are some common DVD configuration. We can put the DVD upper electrode, next circular type of electrode, parallel plated. We can use the DVD on both electrode, upper and lower electrode. We can put the DVD on between the electrodes also. These are the configuration of DVD. So this is one of the homogeneous DVD. To produce the homogeneous DVC, we can put the dielectric barrier attached to the lower electrodes, and we can supply the AC high voltage power electrode, and we can generate the uniform or homogeneous DVD. This is one of the traditional ozone generator with glass tube. We can see the several glass tube are used in parallel to produce the large volume of large concentration of the ozone. So this is the schematic diagram of plasma reactor with produced ozone in our laboratory. So we used the outer electrode and center electrodes, and we have used the 18 kilovolt power supply, AC power supply, and 50 hertz frequency, high voltage but 50 hertz frequency, line frequency, to produce the ozone in single dielectric barrier. This is the schematic diagram of ozonizer. Diagram of ozonizer. You can see the different part used in this schematic diagram. These are the chemical reaction which produce the ozones, where M represent the molecular nitrogen or oxygen. This is the formula for produce the ozone. So we can use this formula to yield to calculate the ozone yield, where eta equal to CO3 is the concentration of ozone, which is in ppmb, parts per million volume. Fr is the flow rate in liter per minute, and P is the discharge power, which is in kilowatt. So it is able to produce the 100 kg ozone per hour, and it is the cost of the ozone at this time is less than $2 per kg. So there are some of the limitation of my work. DVD can be produced within wide range of frequency, but we can use the low frequency, that is 50 Hz also. Only we can use the different type of gas to produce the ozone in DVD, but we have only used the air, nitrogen, oxygen and argon as a working environment or working gas. So in the mechanism of ozone production method, destruction of ozone is not considered. So some of the expected outcome, these are some of the expected outcome from this work. It is expected to help us in designing cost-effective ozone generator with high ozone yield capacity and DVD called plasma reactor, and application in different fields with high efficiency and capacity. The generated DVD non-thermal plasma will be useful for ozone generation and wastewater treatment, as well as for the treatment of drinking water to kill mainly viruses and bacteria significantly. The results of this work will be published, present in conference, seminar, proceeding, and also proceed in related national journal, international journal. These are the references we have used for this research work, and we will also use if required. And acknowledgement, I am very much grateful to these personalities and the institution to provide me the research work, their motivation, cooperation to do this research work. And finally, thank you so much for your kind attention.